Right. So this video is to give an update about the product here. This product is designed um, for changing the mentality around the management uh, control system. So thinking about how AI, how people interact with systems. So I'm going to go through just a few of the core areas. You can see a lot here, but I'll just go on the top level. And um, so the first part we talk about is the strategic part. So unlike where you would be talking to a ChatGPT or something like a interaction, here we're trying to combine all the data, the knowledge, and the processes as something that you're interacting with the AI. So the setup here is more like a Visual Studio, but Visual Studio for business. So it's the idea is that it can have access to all your knowledge base, all your information, and this is for a power user to interact with. So as I would do with code, we have the architecture point of view, we have the developer point of view, we have the tester's point of view, and we're interacting with it. And here, this would be the same. So, I want to perform research, I want to create my strategic plan, I want to refine the KPIs. But the good thing is, if the system is already aware of your data structures and your system, then it's able to build those documents. So in ChatGPT, you'd write it, build a document, you go implement it. Here, you're missing that stage between writing the document and implementing it. You're getting the AI to implement it for you. And using the concepts that you see with Copilot and Visual Studio, there's the agent has the ability to um, interact and perform execution because it has access to workflow engines, it has access to the data, has access to a collection of tools and MCP. So you're working with it. And here the tabs are as you're talking, it can retrieve specific information. So we're talking about um, different, like I want to create a competitive research, then it'll pull up all your documents associated with that competitive research. You can read what's there and then adjust and either create a new agent which will perform the competitive research or execute on the current competitive research. So this will be updated slightly. We have different modes here. um, the code mode I'll go through later because there are parts where we get into that. But for here, we have these models. But the good thing is that we can also choose agents as well. So not just models, agents. And the agents will give us the ability to interact with the way you want to control the flow. So I'll talk about agents um, in a more specific way because agents that generally talk very generically. But here I want to get into the depths of the agents. The other part we have is the document section. So think of your documents, they can be anything, but basically a document here allows us to work with structured data. So what is a document? In this case, it's anything that has a schema. So a document needs to have a schema, which relates to a JSON file. So the idea is that the schema will be your baseline of structured data. So to give meaning to all our research historically, we want a schema, which has a schema definition, which will reflect to a corpus of documents. So that allows us for the AI to correctly fill out information how we want to perceive it, and not just create documents. Although we can also allow for knowledge-based type of documents, which are more unstructured, but here we're targeting to build structured information. So if the AI doesn't have a structure, it'll just generate information how it feels correct. If we provide it structure, then we're giving it an advantage because we're specializing how the AI or the agent represents information. So here we have some base document types, and over time we're going to add more. So these documents become part of the overall plan, become part of the strategy, and they're really kind of the foundation of the brain of how the system works. Uh, I won't, the data sources and other items here is about how you hook in your data sources. So without data, the AI is pretty meaningless, and we need the data in different kind of types, and we also need, um, you know, the knowledge-based kind of data, and we need raw kind of data. So without data, no decisions can really be made, no research can be performed about a business. So we need to hook up the data. Uh, Here we get into I'll just glance over these things. Think about this part of the system as the current situation you're in and developing your strategies. Think about the RevOps side as when we get into the world of simulation. So the more that we understand the business, about the strategies, about the data, the more we can represent the business by using AutoML and other machine learning processes to simulate where we are and where we're going to be. So that is a real focus on the the idea of the future rather than just the present. So, you know, what are we doing today and what we're doing in the future? The GTM is the concept of the interacting, especially with the website, but interactions that might happen as part of your system. So their GTM and GTM strategies like going into LinkedIn or different social medias, sending posts, creating awareness, doing all those campaigns. So where RPA or API activities kind of fall into place, this is designed to specialize in the GTM. And the CRM is just your standard data information. So that is either internal data that's hooked up um, from your data sources or external data that can be used. So I'm not trying to be a CRM here, but the power is that the more we treat data like it's internal, whether it's synced or non-synced, the faster the AI can access it. So, if you were to rely on APIs, you have a very heavy overload depending on the system. So here we're just trying to add in aspects of a CRM. So, you know, AI is not perfect. We still need a certain structure for humans to interact with. So we have all these kind of basic concepts, and I won't go into those screens either right now. So let's get into the meat of it. So the meat is in two parts. The workflow builder. Now, the workflow builder is based on um, a few concepts. So the first is, it's designed more like N8N because N8N is very familiar with people. They like it. We have all the same kind of triggers. The AI agents are very similar. Um, Now I call these, probably need to reword this, but the AI agents are the standard ones. And we have the ability conditions, actions, and events. So unlike N8N, I've introduced more event concepts. So allowing for, kind of event-driven models. And also I've introduced this concept of boundary. So what I'm modeling this off is BPML, uh, BPMN, and it can execute off three engines so far. So we have a Camunda 7, Camunda 8, and also it can use um, PyBPMN, which is still at an early stage. But the idea with that is we allow for boundary events, we allow for sub actions and things. So it goes a bit beyond what N8N can do. But the thinking here is that as the agents develop, there's less humans involved in creating these workflows, that the workflows become something that they're the AI is building and going into. The other observation with using N8N, which definitely serves a very good purpose, is that we have the ability um, to do agents. So, the workflow agents aren't really agents in that essence. They're only AI interactions, which are generally uh, they're generally just kind of like one step. So that's where we move into the um, agents themselves. And here we have the agent screen. So agents, we have different types of agents. Right now we have a standard agent process. So here I have a demo of a teacher talking to students. And here we use an orchestration agent. So the orchestration agent is a coordinator, and basically the information for this agent is going from here, and then it flows to a teacher, comes back, then it chooses a student, comes back, goes back to the teacher, comes back, and this pattern emerges where we're talking about an orchestration agent. Within here, we have the ability to set up our individual agents. So we set up the agents in the sense of these are individuals, so they're either function calling agents. We use Llama Index, React agents, or other type of agents. So Llama Index is very powerful in the sense of its tool calling and its vector. Um, its workflows are good, but probably need some more advanced features on their workflows. So we can see that we define the individual agents, so they are actors. And then we can go ahead and perform simulations, do the vector management, which is what knowledge it can handle. So the idea is if we have vector knowledge, is either a knowledge base or specific knowledge. It can be a combination of everything. So agents need vectors because vectors represent knowledge, and knowledge make them more meaningful. So any kind of agent you have will need to be able to learn from information. So the second type of agent we have is called a handoff. So this is, I think I need two arrows because it looks a little messy. So a handoff agent is the ability to start from an orchestration node. And what happens is that the orchestration node executes, it creates a plan. So the prompts I've been giving is please simulate three conversations between a teacher and a student. Um, in this case, the teacher has a handoff to a good student, and the good student hands off to a bad student. Bad student hands off back to the teacher. Teacher can then either hand off to the student or hand back off to the orchestration. So this handoff is in Llama Index is treated like a tool, and the ability is to create the communication flow between that. So we have the ability to control that conversation between them. Uh, so the last one that we do is a with events. So unlike the other type of agents that we're building, we're building a control of information. So in this case, we have our orchestration goes to the teacher, teacher goes to good or bad student, information gets fed back, and information goes through the done. So unlike other agents, where we're normally doing handoff and plain text, here we're going through a process of an event-driven style of agent where we're going and we're defining. Here we write a description and we define the the um, the data that needs to be passed. So instead of depending on a system command, we're depending on on a JSON schema. And the good thing is that it enforces the structure that's going to be passed from one AI to the next AI. So that allows for a control of information, allows for things like metrifying certain fields and producing a stronger output. So in my experience, especially using OpenAI and doing these tests, having structured data yield a much stronger result than unstructured. So if you need to test someone or perform qualifications or all these other structures, a strong JSON schema is going to do that. So with these earlier experimentations, this has definitely worked out as the strongest way of representing an agent. And also it's very system friendly because you can convert from unstructured to structured data. Structured data can be used in the workflows. So later I'll get into what a typical agent looks like. But right now, this concept of agent is that we build different types of agents. I will be introducing a next one, which will be called the reinforcement learning agent, which will be using the standard LLMs as your assumed knowledge. Um, it will use kind of concepts from reinforcement learning in the sense that it will have objectives and targets that are quantifiable, and then use things like an auto ML or even a different algorithm. I'll probably start with auto ML to create a neural network that represents the information flow. So why would I do that? Is because the most important thing with the agents is the continual learning. You need the feedback loop to know what was good and what was bad. So the agents only have assumed knowledge from OpenAI or Anthropic or Grok, but with models interjected in the bottom, you get extremely better results because now you're basing assumptions or general knowledge with specific data. So, and with specific data, the AI can self-improve. Without this kind of reward system and incremental improvement concept, then it will fail. And part of that will also be you could call it an environment or simulation, it doesn't matter, but the ability to create like use cases, so like you would in development, test cases to make sure your agent is improving but not losing knowledge from the past. So if you have a use case that the results are, equivalent or better than it was in the past, or any loss is a loss for the benefit of a bigger gain somewhere else. So these are the true concepts of like AI agents. So as I said, like here, these agents then can be used in both the IDE the business IDE that I provided, I, I guess IBE, integrated business environment, um, would be useful to do that. So these AI agents will be selectable, so if you have specific ways you want it to learn, it is better. Um, as you capture more knowledge and as added to the vector database, the agents get smarter. And obviously in the workflows like N8N, it the workflow style that we've done, these agents can be a component within that to make the right decision. So a little different to N8N because these aren't going to work the way NAN work because NAN is more like a static one calling functions that move on to the next stage where here we're creating a event handoff or a different type of agent which goes through a rationale to before it hands off. And as I said, like I see that this diagram is not going to be the final, it's going to be something that the agents will control in the future, hence why it's more targeted at a more complicated workflow engine than the kind of linear ones that are presented. So later, I think that's all as a quick introduction, and I'll go through the framework of an agent in my next video. All right, catch you later.